two types of log equations. The first type is when you have logs on both sides of the equation. And one thing that you need to know before we get started is that you cannot take the log of a negative number. So if you try to type in log of -2, you're going to get an error.
Should I write that down?
No, but I'm recording so I can post it for the other class.
Oh, okay.
Yeah. So when we solve these, first of all, we have to make sure that both sides of the equation are completely condensed. So in 7.3, we did properties, where we talked about when you add two logs, subtract, all those properties. We have to make sure each side is condensed. And then, as long as the bases are the same, you can set what's in the parentheses equal to each other. That's what the one-to-one property is. Whenever we get our answer, we need to plug that answer back in to either one of these original equations and make sure that we don't get a negative number in the parentheses. If we do, that means there would be no solution. Okay. So, number one, there's nothing to condense. There's only one log on each side. So we take 5x plus 9, set that equal to 6x. And we solve. So if we subtract 5x from both sides, we get 9 equals x. But we need to check it. And you can check either one. 6 times 9 is 54. So that is, we can take log of 54. No problem. So 9, that's the answer. Number 2, they're the same base. It's fully condensed. There's only one on each side. So let's take 1 minus 4x and set that equal to 2x plus 43. If I add 4x to both sides, this is 1 equals 6x plus 43. And then if we subtract 43, negative 42 equals 6x. So negative 7 equals x. So we need to check that. Now x itself can be negative. That's not a problem, as long as when we plug it in, it turns into a positive. So 2 times negative 7 plus 43. Let's see, that's negative 14 plus 43, which would be 29. So we can take log of 29, not a problem. So that's my answer. Any questions? Number 3, everything's good. Everything's condensed, one on each side. 6 minus 3x equals negative 2x. If we add 3x, we get 6 equals x. Now, if I go plug that back in to either one of them, we would get the same answer either one. We get negative 12. If you try to type in log base 6 of negative 12, guess what? It's not going to let you do it. So this one is actually no solution. So there's no x values where those two logs are equal to each other. Once we get to number 4, we're going to have to start condensing. So we're going to have to think back to the properties that we learned last week. Remember, you did that Google form, the Mad Lib Google form with that. So here I have 2 logs that are being added. If I want to condense them into one log, there's something I have to do with the x plus 5 and the 4. Does anybody know what I do with those? Your properties. When we have 2 logs being added together, what do we do with what's in the parentheses? Multiply them. So this is really log base 9 of x plus 5 times 4 equals log base 9 of 72. And if I distribute, that's 4x plus 20. Probably wrote a little too big there. So we have 4x plus 20 equals 72. So if I subtract 20, we get 4x equals 52. So x equals 13. And if we look back at our original, if we were to plug that in, 13 plus 5 is 18, which is a positive number, yes.
You would have to plug it in though, because log
we know it's 72, yeah. If there's not a log on both sides, you really don't have to plug it in, because you know that. Yeah. All right. Number 5, it looks like it's completely condensed, but it's not. What about number 5 makes it not completely condensed? The 3 in front of the log, and that becomes, I heard it, the exponent. So this 3 becomes an exponent. So it's log of 4 cubed equals log of 4x minus 8. So this would be 64 equals 4x minus 8. So 72 equals 4x. And 18 equals x. And yeah, if you plugged 18 back in, guess what? You're going to get 64. Because you set them equal to each other. So if you don't get 64, then you messed up somewhere. Number 6, this time we have 2 logs being subtracted. So the property tells us that we divide 68 divided by 4. So that would be 16 equals 3x plus 11. No, 17, right? My bad. 17 equals 3x plus 11. If we subtract 11 from both sides, we get 6 equals 3x. And dividing by 3, 2 equals x. Number 7, I have a 1/2 there in front. So that becomes an exponent. What do we know that a 1/2 exponent is? Square root. So this is really log of square root of 25 equals log of 23 minus 4x. One-half exponent is square root, 1/3 is cube root, 1/4 is fourth root, and so on. So this is 5 equals 23 minus 4x. If we subtract 23, we get negative 18 equals negative 4x. And if we divide by 4, we get 4.5 equals x.
This calculator is running that.
Okay. Come bring it up here and swap with one that's charging. Number 8 kind of has 2 things. This 2 needs to become the exponent, and that 6 and 4 need to be divided. So this is log base 3 of 2x minus 5 equals log base 3 of 6 squared divided by 4. So our equation, 2x minus 5 equals what? 9. 36 divided by 4 is 9. X equals 7. Now on the back, before we get started with the examples, I'm going to change these last 4. Because those end up using quadratics, and I really don't think you want to deal with that. So. And we'll just do 2 extras, I guess. Instead of 4. All right. Let's see. 1 plus log of x minus 6 equals 1. And log of negative 5x minus 10 minus 9 equals negative 5. We'll just do those. 4. So get those copied down. All right. So in order to solve these, first we need to condense. So these are the ones, I should say type 2, but a log equals a number. So we only have log on one side. Got to condense your log and get so we only want the log. We don't want anything added, subtracted, or multiplied outside of that log. Got to get rid of anything else. And then, if you remember back, we converted them. We drew this like loop-de-loop thing, like the backwards loop. So we're going to convert it to exponential form. We're going to write 2 to the 6th power equals x minus 4. So we practice going back and forth between log and exponential, and each time we draw that little backwards loop. Now we know we can find 2 to the 6th power. What is 2 to the 6th? 64. And then if we add 4 to both sides, we get 68 equals x. And we do always need to check these. 68 minus 4 is 64, so we're good. It has to be positive. That's all we care about. Number 10, notice I have this minus 7. We have to get rid of that first by adding 7 to both sides. And then we can draw our loop. 3 to the 4th power equals 4x plus 8. What is 3 to the 4th power? And solve for x. $73 equals 4x. Yep. So if we plug that in, 4 times a positive number plus a positive number, you don't even really have to figure it out. You know it's going to be positive. Number 11. First off, we need to subtract the 1 for both sides. I don't see a base on this one, but what do we know that it is? 10. We kind of need that to do our loop. So 10 to the 0 power equals x minus 6. What is 10 to the 0 power? 1. Anything to the 0 power is 1. And then if we add 6 to both sides, we get x equals 7. And if we look back and we plug that back in, yes, 7 minus 6 is 1. So we're good. A lot of these times that you do quadratics, you will have extraneous solutions. You'll have ones that give you negatives that don't work. Number 12, we need to add 9 to both sides. So this would be 10 to the 4th power equals negative 5x minus 10. What is 10 to the 4th power? 10,000. And if we add 10, we get 10,010. And if we divide by negative 5, we get negative 2002 equals x. Are there any questions? Now, these 4 lessons that we've done will show up on your final exam. So there's a section on this. All of the other sections on the final come directly from your notes packet. So if you have those, you're in good shape. If you don't have those, we're still going to review for the final, and you will still have practice. You should still be okay. It's not a hard final. I mean, you'll have to remember some stuff and do some stuff, but it's not, I don't think it's a hard final. So